First, good morning, good afternoon, and good evening to all of you. My name is Wenbin Zhang from United Nations Office for Outer Space Affairs. Welcome to the Access to Space for All series of webinars on conducting research and development in the hypergravity, microgravity. Thank you for joining our first webinar. In this webinar, we will provide some technical insights and knowledge on where to begin and how to further your research and development endeavors in this exciting field. So this is a series of webinar. It will took place ever since today and last to mid of the June. So there are 9 webinars are planned. And please don't hesitate to continue register to our following webinars. We will send the registration link in the chat box. And also you can find it on our Access to Space for All webpage. Okay, before we begin, I would like to explain a few things about the logistics. So first, to all participants, please make sure to turn off your cameras and your microphones. Yeah, we can mute you, but we cannot turn off your cameras. So please make sure the camera is only available for speakers. And second, if you have any questions or comments, please do not hesitate to put in the chat box. We suggest that you make the chat box open, so because me and my colleague will post many useful links there, and we hope you could have a warm interaction with us. Any questions and comments are welcome there, and all your questions will be addressed at the end of the webinar. And later we will put a questionnaire form link into the chat box, so please make sure to answer that before you leave the webinar. We really appreciate if you could do that because it helps us to improve in every webinar we host. Also, if you use social media, please use the hashtag #AccessToSpace4All to help us promote the webinar, and also follow the tag UNOOSA on Twitter, LinkedIn, Facebook, and Instagram. Last but not least, this webinar will be recorded and you can find the video on our website maybe a few days later, and all the slides we used in this webinar will be available on that web page later. Okay, so let's start our today's webinar. The schedule is listed here. First, my colleague, Ms. Hazuki Mori, will give a short introduction to the Access to Space for All initiative and hypergravity, microgravity track. And Dr. Jack Van Loon will give an introduction to hypergravity and microgravity. After that, we invited 3 speakers from different continents to speak about activities of existing hypergravity and microgravity research networks. And after all the speakers, we will have a chance to have our speakers here to answer all your questions. So don't be shy. If you have any questions, leave it in the chat box. Okay, I might have talked too much, and I will hand the floor to my colleague, Ms. Hazuki Mori. Hazuki, the floor is yours.
Again, thank you for joining in our webinar today. My name is Hazuki Mori of the United Nations Office for Outer Space Affairs, and it is my pleasure to introduce you to this exciting webinar on hypergravity and microgravity. So before we begin, I'd like to explain about the activities of the office and why we're doing these webinars. So as you can see here, we have been organizing the Access to Space for All initiative from 2018. And this all comes from our past activities when we were doing more of theoretical activities through regional centers, workshops, fellowships, and all that. However, there was a strong need for hands-on opportunities. As we say, you can't learn how to ride a bike by reading books about it. You really need to actually get on the bike and get your hands-on experience through it. So the Access to Space for All initiative is a collection of opportunities that you can do hands-on actual experience. So the goal of the Access to Space for All initiative is, as you see here, is to provide research and orbital opportunities for UN member states to access space and to ensure that the benefits of space, in particular for sustainable development, are truly accessible to all. And we do this by providing access to unique ground and space infrastructures that are usually too costly or non-accessible to developing countries. And we do this free of charge. And as you can see here, we have a wide range of partners, from intergovernmental organizations to industry partners. And partnerships are truly a distinctive feature of the initiative. These partners provide the access to the state-of-the-art facilities. They provide a lot of the support to the development of the technologies and the scientific capabilities. I hope you're seeing the next slide. This page explains about the values of our initiative. As you can see here, first of all, as I've explained earlier, this initiative provides hands-on capacity from A to Z in a responsible and sustainable way. What I mean by A to Z is that we provide gradual learning steps, starting small and leading to complex skills. And what I mean by responsible and sustainable way is that we provide support for teams to comply with international guidelines, for example. Next, for social impact, it basically has a very big impact to your country, region, and young generations. For example, one of the opportunities we have under this initiative called Kibokub, which is an opportunity that you can deploy a small satellite. Through that Kibokub opportunity, a team from Guatemala actually involved 100 young students to develop their first satellite, Quetzal-1. As you can see here, 100 young and motivated students is a great result, and it's a wonderful way that they can tackle the problems of today and the future. Also, with what else comes with social impact is that with more interest in STI, science, technology, and innovation, there are more chances that you can get investment to STI, which will help with the infrastructure and the education of your country. Next, this initiative fosters international cooperation. A lot of our opportunities are provided by spacefaring nations, and we try to get developing countries to join in. However, we can see that there's a lot of teams now that apply to our opportunities that are already teams coming from 2 different countries or 3 different countries. So we see a lot of international cooperation within the initiative, within the project itself, and within the teams that try to apply to it. So we're fostering a lot of international cooperation in the initiative. And lastly, through the initiative, we can provide cutting-edge skills for jobs and other opportunities. Okay, so next, the Access to Space for All initiative, what I've mentioned earlier, all the benefits that I've mentioned in the past slide, sorry, all the things I've mentioned, all linked to the 17 Sustainable Development Goals of the 2030 Agenda for Sustainable Development. So this agenda has been adopted by all member states, and it is a global mission to reach these goals by 2030. Space is truly relevant to the SDGs, and it can really help achieve them in so many different ways. Our office, in collaboration with the European GNSS Agency, published a report in 2018. Maybe my colleague can put up the link later, but we demonstrated that Earth observation and global navigation satellite systems can support the SDGs. So nearly 40 of the targets that are underpinning these 17 goals can be supported by space technology. Whoops, next. Okay. And as you can see here, as an initiative, we especially try to foster SDG number 4, which is quality education, and number 9, industry, innovation, and infrastructure. The technology and infrastructure that the participating teams achieve and the various applications coming from all the different projects contribute to the SDGs. For example, another one from Kibokub, the winning teams build infrastructure such as ground stations. And also a new opportunity we have called ISONScope, which is the provision of telescopes. The winning teams will achieve telescope infrastructure for astronomy. So as you can see here, we're not just providing one-shot opportunities, but we're providing the infrastructure and also the education. Okay, I see. I hope you're seeing my next slide. In the initiative, we basically ask applicants to make links between their projects and the SDGs in the application forms. And as you can see here, as an initiative, we said 4 and 9, but you can see that the many different projects link to so many different SDGs. For example, Tumors in Space, which is a project that is being run under the China Space Station collaboration. They're doing tumors in space, which directly links to good health and well-being, SDG number 3. Another example is that one of the satellites developed under the KiboCube opportunity was monitoring water, which means it links to SDG number 6, clean water and sanitation. So the next page is talking about some former projects we used to do. That relates to modified gravity. So in the past, we have organized opportunities to distribute clinostats to promote space education and research under microgravity. Also, we have organized a teacher's guide on how to use these clinostats for plant growth. However, right now, our Access to Space4All initiative looks like this. We have a collection of 8 hands-on opportunities under 3 different overarching themes that we call tracks. Basically, our webinar will focus a lot on the first track, which you see on the top, the Hypergravity Microgravity track, but they all have relations with the other tracks. I'm going to give you a brief explanation here. So for the Hypergravity Microgravity track, its goal is to develop capacity of running space experiments onboard orbital vehicles or space stations. On the left-hand side, you see 2 programs that are done on the ground. And on the right-hand side, you see 3 programs that are done on orbit. And in the middle, you see a little red donut, which is an identified gap, which means we don't have a program here yet for suborbital and parabolic flights, but we are really hoping to organize one for you in the future. And we are in discussion with potential partners. So as you can see here, we have drop tests, which is using the Bremen drop tower, and it is actually open for applications right now until June 30th. I'll explain that later. And going to the satellite development track, you see 2 on-orbit opportunities. One is called KiboCube in collaboration with JAXA, the Japanese Space Agency. This allows a deployment opportunity from the ISS. You see another one called Vega C. This is in cooperation with Avio, the Italian company, and this is an opportunity to deploy the CubeSat directly from Vega C. On the left-hand side, you see another identified gap about CanSats. We hope to provide that soon as well. And lastly, in the exploration track, this is a new track actually that we've opened this year. It covers aspects related to space exploration beyond the geostationary orbit. We have one opportunity called ISONScope open. As I mentioned, it's a provision of telescopes. For these opportunities, everything is on our website. Please make sure to check them out if you are interested. So I'd like to go into the details of the track, especially the Hypergravity Microgravity track. But before, I'd like to mention that KiboCube, Vega C, all those opportunities can relate to things from the Hypergravity Microgravity track. So it is another general learning step to the Hypergravity and Microgravity track, because you can test, you can use the 1U or 3U CubeSat to test anything regarding microgravity. I mean, you're going to be put up in space, so that's another step that you can see. But first, I'll explain about the Hypergravity and Microgravity track. So this is drop tests. As I've explained earlier, it is an opportunity to conduct a series of microgravity experiments at the Bremen Drop Tower. It is in collaboration with ZARM, the Center of Applied Science, Technology, and Microgravity, and DLR. As I mentioned earlier, this is an open opportunity, so please make sure to check out our website if you are interested. As you can see, we have been conducting drop tests from 2014. We already have 7 winners from many different countries, and you can see that the objectives, what has been done in these experiments are totally different. They vary from material science to biology. So as you can see here, there are many things you can do in our opportunities. Next, we have Hypergest, which is in collaboration with the European Space Agency. So this one provides opportunities to conduct a series of hypergravity experiments at the Large Diameter Centrifuge Facility at ESA. And we're hoping to open applications for the next round this year. This is a new program. We started it in 2019. We only have one winner from Thailand that will study the effect of hypergravity on water meal, and we haven't been able to test it yet, but we hope to do it this year as well. Next, we have Bartolomeo. We're shifting to the on-orbit opportunities now. It is in collaboration with Airbus, and we provide institutions with the opportunity to put their payload on the Airbus Bartolomeo external platform. And this is going to, the first round winner will be announced soon. So after that, we hope to open more opportunities. Next, we have the Chinese space station opportunity in collaboration with China Manned Space Agency. So this is an opportunity that we provide opportunities to conduct your own experiments on board a Chinese space station on either outside or inside of the CSS. And this is another great example of international cooperation because we found 9 projects involving 23 institutions from 17 different member states, and they have been selected for the first round. And finally, we are working with Sierra Nevada Corporation to use their Dream Chaser vehicle to provide space mission experiments. We're still in discussion with them. We hope to open them as soon as possible. So I've explained the activities of the office, but now I'd like to dive into what you can find from these webinar series. So today is the introduction of hypergravity and microgravity. Next, we will dive into the different scientific topics. So life science R&D, we'll have biology, physiology, pharmacology. Next, we will have physical science R&D, which will be talking about material science, fluid dynamics, and then we will be talking about technology demonstration. So we really want to get into focus about these different scientific topics and really open your eyes and show you the different things that can be done there. And also the last 2 webinars will be available opportunities and regional activities. Available opportunities will be elaborating on the opportunities of UNOOSA. So drop test, hyperjazz, all that I've mentioned earlier. Our partners will be there to explain more in detail about the technology, about the details of the opportunity. And last webinar would be regional activities. So we've invited space agencies and many different corporations that are doing different activities in their different regions. So you'll be able to understand what is being done in the world, not only your region, but in the world. And the learning, the lessons that we want to be able to provide is the fundamentals, the special characteristics, the advantages of this hypergravity and microgravity environment. So in order for you to actually do hands-on experiments, to be able to conduct actual experiments, in these webinars, we're trying to give you theoretical knowledge, theoretical information, and things that can really help you to and support you to actually do those experiments. So as I've explained, we really want to give you the fundamentals. And also we want to give you the overview of what type of research can be done through these different scientific topics. We also want to give you an overview of the available platforms. So we have our opportunities, but we have the regional activities as well. And also we want to let you know how to develop an experiment. So in each of the scientific topics, our partners will elaborate on that as well. And lastly, we want to give you an overview of the available opportunities and the existing networks so that you can reach out to them when you're interested. Okay, so lastly, the updates to the agenda and all the recordings and the presentations of these webinars will be uploaded to our website that you can see here. Also, we put our recordings on YouTube, so you can also check the YouTube channel. But everything will be uploaded to the website, so please make sure to check that out. Okay, I feel like I've talked way too long. I'm very sorry. If you have any questions about the webinars, about the opportunities, well, basically about anything, please feel free to contact us at UNOOSA access2space@un.org. Okay, thank you very much.
Yeah, Hazuki. Yes, dear all, if you have any questions, please leave them in the chat box. I have seen a few questions there. It's very good. So next, I would like to invite Dr. Jack Van Loon to give us an introduction to hypergravity and microgravity. And before that, I would kindly ask every guest to turn off your camera and the microphone, please. And yeah. Okay, so Dr. Van Loon is a senior expert in hypergravity and microgravity area. He was the vice president and 2 terms president of the European Low Gravity Research Association, ELGRA, and 1 year president of the International Society of Gravitational Physiology. And he has been a board member of the American Society of Gravitational and Space Research, ASGSR. He was involved in various Dutch and ESA projects, and he's now a cooperating scientist at the TSC MMG lab of the European Space Agency Technology Center, ESTEC, in Noordwijk, Netherlands. Okay, so Dr. Van Loon, the floor is yours.
Well, thank you very much for the introduction. Do you see my screen?
Yes, I can see your screen.
Okay,
it's perfect.
Good. Well, thank you for the introduction. To me, the honorable task to say something about hypergravity and microgravity research. So I try to do my best. Of course, there's a lot of slides I included in here, but I can only touch upon some of the things involved. If you want to have more details, then we can discuss it later, or maybe have other means of contact. We're talking about gravity, and gravity is one of the 4 forces we have in nature. Besides the weak nuclear force, the strong nuclear force, and the electromagnetic force, we have gravity. But gravity is the one that that works over the longest distance compared to these other forces, which are really on small scale. And in this slide, I show you 24 orders of magnitude where gravity plays a role, coming from a molecule all the way up to the Milky Way. In general, gravity has mainly an impact on these 5 issues here. Gravity has an impact on weight, hydrostatic pressure, convection, buoyancy, and sedimentation. With respect to space flights, of course, there are other variables like isolation, radiation, and the environment as such. But let's say on most of the physical and life sciences experiments, these parameters play a role. If we look to gravity and mass, or gravity and weight, you're probably familiar with the fact that when you have mass, that mass attracts each other. In our solar system, we have a huge mass in the center, being the sun, and then we have the orbiting planets. And because of the mass of the sun and the mass of the planets, they attract each other, and they orbiting around the sun. But we can generate gravity another way, and that is to make use of centrifuges. So we have artificial gravity. And in order for gravity to have an effect, you need mass. And if you apply gravity to a mass, you generate weight. And the more mass you have, and in this, we did a very simple experiment in our centrifuge at ESA ESTEC, the LDC, where I had 2 balloons, one filled with air, one filled with water, and we applied gravity to them. And what you see is that the impact of gravity on the water filled, so the heavier, the more mass object, has a much higher effect than to the lower mass object. So for gravity to take an effect, you need mass. This is my simple representation of the human body, where you have the body standing in a gravitational field, and then you also have hydrostatic pressure. You have more pressure in your legs than in the upper part of your body. And this plays a role in the physiology of your system. In this case, we have a huge length body, being a giraffe, and what you see in this animal is that it really adapts its anatomy because of the high pressure of liquids you have in the lower part of the body of this huge animal. If it wouldn't have such strong structures in their vessels, the animal would literally bleed to death, more or less. So you need to adapt because of this high pressure which is generated by this gravitational field. Another example on that is on these snakes, and they live in trees, on ground, or in an aquatic environment. And depending in which environment you live and depending how your body orientation is over your lifetime, you see that the position of the heart with respect to the head is different, where in the aquatic one, the heart can be much further away because it lives normally in a horizontal situation, so you don't need to cope with this different hydrostatic pressure all the time if you compare that to this arboreal or this tree living snake. Convection is another one. You're probably also familiar with if you boil something on the stove, you see some your fluid movements within the liquid, within the water, but you also have it on planetary scales where you have these lithospheres moving because of the convection in the Earth crust. But if you do these convection experiments, or if you want to get rid of this convection, you can do these experiments under near weightlessness or microgravity conditions. Here you see a very, let's say, simple experiment with a flame, either in 1G, where in 1G you have this convection, where you have your hot air going up, you have your cold air coming in, also carrying the oxygen. So this is how you keep your flame burning. But when you do exactly the same experiment under microgravity conditions, you get this kind of flame. This is the fusion limited combustion flame, which is a totally different as you compare that to your 1G condition. This same phenomena you see also in crystal growth under microgravity conditions. You normally can get larger crystals, but also more purified crystals because of the slow growth compared to this diffusion limitation. So you can use the microgravity environment to grow, very, very large crystals if needed. Or you can also look in buoyancy and convection here in a heat-driven loop. This was an education experiment by the European Space Agency some time ago. You have other convection phenomena like the Bernard-Marangoni convection, what you see here, or the surface tension dominated convection, the Gibbs-Marangoni convections. These convections are not gravity dependent. However, there are quite some experiments done under microgravity conditions looking into these phenomena. And the reason for that is that you have a much clearer view on the microgravity near weightlessness conditions looking into these phenomena because you do not have the gravity driven convection anymore. So you can have a much more cleaner experiments in spaceflight microgravity conditions on these phenomena. Convection is also very important if you want to grow plants in a microgravity environment. It's very relevant for the upper part of growing plants because of the, let's say, the micro environment you create around leaves or leaves and flowers of these plants. They don't grow under microgravity conditions if you do not really actively, have a forced convection in your system. But also in your root system, the microgravity plays a large role in how to get fluid to your plants as they would normally do on a 1G or in a gravitational field. So it's not trivial to grow plants under microgravity conditions. You need to make various adaptations to do so. Sedimentation is another phenomenon, gravity driven, and I think we're all familiar with, if we have a liquid or the water and sand, that the heavy particles will settle in your cup. But you also have that in biology. Actually, that's the basis why plants stems will grow up or roots will grow down. It's because they have these heavy starch particles in the lower part of the cell, and because of that, they will settle because of gravity. And because of this orientation, the plant knows what the direction of gravity is, and in the opposite direction, it will grow its stems, and the downwards direction of gravity, it will grow its roots. So that we see also in these rhizoids, when you do that under microgravity conditions, you have a complete redistribution of these starch granules within these rhizoids, and I have another example of that later on. You can use gravity or hypergravity or microgravity to do studies, for instance, also on waves. And this a typical experiment, I think it's a nice example of how you could do an experiment where you both make use of the microgravity environment here on the ISS or in a parabolic flight, or you make use of the ground-based facilities we have, and in this case, making use of the centrifuge, the LDC at ESA. Where you see under microgravity conditions, you can specifically study the capillary-driven part or the capillary part of waves, or in hypergravity conditions, you can study the more mass or gravity-related behavior of waves. So this is a nice study just recently published, and you can look this up in the PDF later on. So gravity-related machines, I mean, if you want to do research, there are all kinds of facilities or machines you can make use of. So you have either facilities to look into hypergravity, so centrifuges and magnets, or in areas of hypogravity, either in real microwave or microgravity or in simulators. So centrifuges, this is a small centrifuge we work on the LDC. I will explain some more. This is the MV-Hub human centrifuge at the DLR in Cologne in Germany. You can also make use of magnets to generate hypergravity. And there's a large human centrifuge also in Soesterberg in the Netherlands on that. A very, let's say, attractive area is to make use of microgravity simulators. These are not generating microgravity, but you can use them on a daily basis, relatively cheap and easy, but they simulate microgravity. So it's not a real thing, but you can learn a lot making use of these facilities. And of course, you have the real microgravity facilities, the parabolic flight, the suborbital ones. You have some lectures on that later. The Soyuz and the Dragon Lab free flyers, the International Space Station or the upcoming Chinese Space Station, and the drop tower is also part of it, of course. So really look into all these facilities and see which one you can use best, and especially for the ground-based one, use it as much as possible because it helps you preparing also for a real spaceflight experiment. So in that sense, for the ground-based research, there's no space without ground. So how can you make use of these ground-based facilities, and in this case also centrifuges, to learn what might happen under other gravity conditions? Well, one of these phenomena is the gravity continuum, where you go from microgravity or microwave all the way up to X-gravity and whatever the X is for your particular experiment. I mean, on ground you can do quite easily experiments making use of centrifuges going from 1G to XG, and you can do various measurements at various G levels, and you can extrapolate that data to predict what might happen at the lower G environment. Yeah. So you can do, although it sounds a bit funny, you can do microgravity related research making use of centrifuges in this gravity continuum phenomenon. The other one is the reduced gravity paradigm, which also makes use of centrifuges. This is a regular microgravity experiment where you are on Earth at 1G, you're launched, and then you go into a microgravity environment, and then you do your measurement, you have your microgravity response or your adaptation while under microgravity conditions. You could do a similar thing, not the same, but a similar thing going from a hypergravity situation like 3G or 2G and going to a lower G with respect to the initial G level. So you also have a reduced gravity here compared to what happens if you go under real microgravity conditions. So you have a reduced gravity condition here, and the hypothesis here that the adaptations you will have in this situation are similar to the one under real microgravity conditions. Not the same, but similar, and it depends a bit on the phenomena you're looking into. But again, it's an easy way to simulate, between brackets, microgravity on ground making use of centrifuges. This is an experiment we did some time ago where we had a zebrafish, a small zebrafish in the LDC at ESTEC. And in this case, we looked into mineralization of this animal. Here you see the mineralization of the inner ear otolith, which is vestibular system mineralization. Under control conditions, under 3G conditions, you have less mineralization under 3D conditions in these animals. On the other hand, if you look into the mandibula, so the jawbone of these zebrafish, 6 days old zebrafish, you see less mineralization in the control compared to the 3D loaded bone in these animals. In general, you can say that in these animals you have more mineralization under 3D conditions compared to 1G. And it goes too much in detail now, I cannot explain, but this experiment we also use to look into some aspects of gene expression with respect to the reduced gravity paradigm. Centrifuges can also be used into, let's say, more infectious related or immune response related experiments. This is a very nice experiment done a couple of years ago with Drosophila, and you will hear more about Drosophila later in this series of webinars from NASA Ames in California. Effects of hypergravity on post-infectional survival of these Drosophila. And what you see in these animals, and I want you to focus on these two lines, is when you infect these fruit flies with a fungi, that they will die after a while. This is what you see here in the blue line. So after 15 days, some 55% of these animals will die. However, if you expose these animals to 4G, the green line here, then you see that the survival rate goes up. So more animals survive if you expose them to a hypergravity environment. So somehow gravity has a positive effect in these infectious diseases. Another way to use centrifuges is to extrapolate and to predict what might happen under lower G environments. So this is an experiment from the University of Glasgow we did some years ago, where they looked into the test of the ultrasonic drill at high gravity conditions. This is the drill in the centrifuge gondola. And they were exposed to various G levels, 5, 3, 2, 1.5, and 1 G. And this is what you see here in these measurements, where they started off in these dotted lines, where they had a model where they predict what might happen under these various conditions, so a numerical model. And the solid lines are what has actually happened in the centrifuge. And what you can see, doing these experiments, they could adapt their model to the actual test results. But what you can also do is to extrapolate your data to a lower G level. So you might predict what might happen if you would use such a drill, for instance, on the moon or on another celestial body. Ground-based research, microgravity simulation. One of the earlier systems used on that is the clinostat, and it was briefly touched upon on the GSIP program explained earlier this morning. Clinostat is actually a very simple device where you rotate, in this case, a plant around this, in this case, horizontal axis. If you do that with a plant, it just goes straight. If you remember, from the garden or other places, if you would have placed a plant in this orientation and you would just leave it, it will grow up again after a while. The stem will grow up again. But if you constantly rotate this plant, it will not grow up, it will just grow straight. And it does so because it cannot integrate the force of gravity, the direction of the gravity vector over a period of time. So you nullify the gravity vector and you get similar results as you would do under real microgravity conditions. Well, this is a 2D clinostat with von Sachs. Nowadays, a lot of experiments are using a 3D rotating device, so you have a volume you can use to simulate microgravity. And again, it is a simulation, it's not real microgravity, but you generate a sort of disorientation for these samples. The same in this case for human physiology. They used it in the NASA Mercury program decades ago. But you see this orientation of these roots in this random positioning machine. Roots grow in all directions, and in the 1G conditions you see that you have a more oriented root growth in these systems. You also see gene expressions in the Drosophila experiment we did together with the University of Madrid with Roberto Marco and Raúl Hans. You see that the gene expression in these animals are, let's say, not the same, but quite similar to the gene expression under experiments done on the ISS as compared to the random positioning machine. We have a more sophisticated version nowadays of these random positioning machines, and this is what we have in the lab at ESA. where we have a regular random positioning machine, as you explained to you earlier, but we also have a modified version where we have algorithms running where you can software-wise generate, for instance, Moon G or Mars G or any G level between 0 and 1. Or we have a hardware version to generate partial gravity. In this case, you have simulated Mars gravity in this device. So it's a new way of generating partial gravity, and with the upcoming exploration research, I think it's an interesting possibility. But again, keep in mind, it is a simulation. It's not a real thing. So some cell mechanobiology, mechanomics and physicomics, as some of these terms you might run into sometimes. What we do in gravitational cell biology is that we want to study direct or primary effects of gravity acceleration onto a cell. You apply or remove a mechanical load, in this case gravity, you get biochemical messengers, and the cell adapts. You have mechanotransduction, and the cell adapts either in structural changes or functional properties. And the end result is that the cell either adapts to this new mechanical situation you apply it to, or you have an injury to the cell, or it even dies. And this is what you want to study. You know, how a cell responds under the various gravity or microgravity conditions. So this is a very general experiment we did with a bone cell, where we took an atomic force microscope, where we looked into cell height at various gravity conditions. So this is the same cell looking with this AFM onto the cell surface. And what you see here is looping this cell between 1 and 3G, where you see some of the cytoskeleton structures here changing at high G conditions. So the cell gets more flatter if you go to a high G level. If you look at various studies looking into what the effect of microgravity is on cells with respect to the cytoskeleton, this is what you see in a very general picture. This is a cell at 1G, or a model cell at 1G, or a model cell at microgravity conditions. And you see huge changes with respect to the cytoskeleton. Your actin fibers are changing here, they're going more to the periphery. Your intermediate filaments are more concentrated around the nucleus here, and also the straight structures you are familiar with the microtubules you have at 1G conditions is also totally disrupted under microgravity conditions. This is a general, let's say, an overall view of what might happen at the cell level. And I think this is the challenge we have to go to in the years to come. Where we have these phenomena like what I explained to you earlier. You have a cell, you go into mechanoperception. So how does the cell perceives its mechanical environment? You have a change to the cell, you have a transduction somehow from this signal, and then you have an adaptation. You can divide these processes in various areas, where what I showed you earlier was more the cytoskeleton part. So the morphological changes you have, but you also have a lot of biochemical changes, mainly in this part. But I think what the most interesting part here is, you know, what the mechanoperception is of the cell. So how does it see gravity or microgravity, and how does it respond to it? So I think this is the area, where we should focus on the coming decades with respect to gravitational research. So the mechanobiology or the mechanomics really describes this whole field of how the cell responds and adapts to the gravitational area. In space research, you find very general. You find two main areas. You have the basic sciences, what is done, on space stations, on free flyers, on rockets, or on centrifuges. Or you have operational sciences. And operational science is mainly to have your spacecraft working from a physical point of view, or to keep your crew healthy and happy during their activities under spaceflight conditions. So there is quite some overlap sometimes between these disciplines. There's also a feed from the basic sciences towards the operational sciences that you add to the environment you have in space, and that is the role you have in basic sciences. What we have now also in, human-related research is that it's really, we have to think about if microgravity is really something we want to expose humans to for a long period of time. I mean, there are some thoughts, including myself, that we think that microgravity is really pathological to the human physiology, and there are some ethical issues you might address, you have to address for future long-duration space flights, and we've made a paper on that recently. In that sense, because of this ethical issue and anatomical or functional changes in these astronauts under microgravity conditions, there are various studies to see whether we could use centrifuges on board to mitigate these effects, or maybe abolish these effects. So small, short radius centrifuges, some work done on that, or large radius centrifuges, and this is a project we work on with some people to also have a very large centrifuge on Earth somewhere to look into hypergravity on the human body, and to learn how the human body responds to mild periods of weeks or months under, mild hypergravity conditions, and to learn about that. I'm not sure whether I am in time, but thank you for your, thank all the people who somehow added to this presentations, and thank you for listening.
Well, thank you for the introduction, and Hazuki, thank you for the introduction to the program. I think it's a really good transition to what I'm going to be talking about. So I won't dive too deep into the technical details. I'm going to just give a general top-level overview of hypergravity and microgravity research, the platforms, and what's being done currently in this sector. As you all heard of the agenda for the rest of the webinar series, there's going to be a lot more opportunities to dive into each area more technically with experts in the field. In addition, totally recommend everyone to stay on afterward, after my presentation, to hear from the associations. It's a great opportunity to get some resources into the field, be able to network with experts and students doing research in the field. And also, there are great resources of information on funding opportunities and flight opportunities as well. So I just completely recommend those presentations after mine. So yes, I'm Sirisha Bandla. I work currently as the Vice President of Government Affairs for Virgin Galactic. I'm also a board member on ASGSR, but I do work with the microgravity community, especially on creating and developing payloads for flight on Virgin Galactic's suborbital vehicle. So my expertise lies in the suborbital side, so I'm happy to answer any deeper questions on that side, but for my presentation, I'll be talking much more top level. So just really quickly, so everyone's on the same page, what is the hypergravity and microgravity environment? Of course, microgravity, of course, is the environment in which we don't experience the effects of gravity that we feel here on Earth, whereas a hypergravity environment is environments where the force of gravity exceeds the gravity we feel here on Earth. And it's important platforms to access that environment to study what the effects of gravity are by removing or exaggerating the effects. So it's been used quite a bit in the past, and there's been a lot of interest moving forward with new vehicles appearing in the market to be able to access these environments. You see a lot of research being conducted in these environments to test components and research for space-based applications, i.e. testing components to survive some of the accelerations that they feel during the launch process, and to be able to work in a reduced gravity environment once on orbit or going to a further destination. However, I hope everyone realizes that a lot of the research being done in these environments also help us fundamentally understand the processes and the environment we live here on Earth. And a lot of the technologies and a lot of the work being done is really to improve our life on Earth. And it's just a really exciting field. And I'll talk a little bit more about some of the work that people are doing and how you can access this environment. The image you see here in the presentation was from one of our previous flights on Spaceship Two, which is our suborbital vehicle. You can see the two pilots in the cockpit, and behind them we have Beth Moses, our chief astronaut trainer, as well as some research payloads in the cabin, which you can't see here, but just a very cool picture. And hopefully one day we'll see a lot of you in the cabin there as well. So as I mentioned, and Hazuki actually mentioned in her presentations, there's quite a broad range of fields that are utilizing hypergravity and microgravity environments for their research. I've just picked out a few examples, but really the fields that are being utilized in this area is quite broad. These are some of the fields that I have been seeing more frequently coming from the suborbital side. But physiology, especially, is one, just studying the biological responses to identify just the processes and mechanisms which govern our bodies on Earth and how we can more comfortably adapt to extreme environments, whether that's space for long durations on orbit, deep space exploration in the future for human spaceflight, or some of the extreme environments we have here on Earth that a lot of people do use for field research. Plant science is another area where the community is studying. Obviously, gravity influences the plant growth on Earth, but what is that influence? And researchers are utilizing microgravity and hypergravity environments to do that work. And it provides insights into plant biology that, again, help us should we want to utilize, for example, growing our own food source, deep space exploration missions, or to help adapt crops for the changing environment on Earth. So multiple applications for all of these fields of research. Fluid physics, learning how fluids behave, lots of just fundamental research to understand the phenomena, and its fields, it actually spans multiple fields. I've seen a lot of fluid physics work being done, testing out components for applications on ISS and other spacecraft. But there's also quite a bit of applications on Earth as well. So I guess you guys are all hearing a theme. It's not all, even though microgravity and hypergravity, sometimes we think about space-based research, a lot of this work actually has a lot of applications to what we're doing on Earth. Next. So what are some of the platforms that you can utilize to do some of this research? So starting with hypergravity, I think one of the most common ones is the parabolic aircraft. Right before its pull-up maneuver, you can get about 2 Gs for about 20 seconds, and a lot of researchers utilize that hypergravity environment for their work. The parabolic aircraft is a very easily accessible platform. Multiple companies around the globe offer these services multiple times a year, and the cost is pretty low compared to other options. So it's been a very popular platform for research. Two here you see are centrifuges. One Hazuki actually talked about, the large diameter centrifuge by ESA. Very unique platform. Can host multiple payloads at a time. It can go up to, I believe, almost 20 times the G level that you feel on Earth, and can sustain that rotation for months at a time. So it's a great option to conduct longer term research. Growing samples, for example, would be ideal for this kind of platform. The image you see at the bottom, I'm not sure if you can all see my cursor, but I am circling it. It's the centrifuge that is operated by NASTAR, and is quite often used for training purposes for pilots and astronauts, future astronauts, to get them acclimated to high G, but also has been used for physiological, for research, understanding the physiological stresses of high Gs on humans as well. Now looking at microgravity environments, I'll start with my least favorite platform. That is this drop tower of doom. I'm not sure if anyone has been forced to go on this ride at amusement parks by their friends. I don't particularly enjoy it. I'm just kidding. I just wanted to make sure you guys are still with me. These are actually the platforms that are used pretty commonly for microgravity research in our fields. Again, Hazuki actually mentioned the first one that you can see here on the left. This is actually an image of the ZARM drop tower by DLR, but a lot of universities and a lot of research organizations actually have their own drop tower. Again, a very easily accessible platform, provides a short duration of microgravity. It's just seconds. The ZARM drop tower actually provides about 5 seconds for a drop, or they have an option to do a catapult launch, which catapults it up and then drops, and that provides almost 10 seconds of microgravity. For drop towers, the payload size needs to be typically small, which can constrain some research, but for many, that is enough. And again, it's very easily accessible. The cost is low, so it's a very popular option for microgravity research. The second here is a parabolic aircraft, which I mentioned in the hypergravity portion, but again, provides about 20 seconds of microgravity time and could do multiple parabolas, 30 to 60 for a typical flight campaign. Again, easily accessible. Multiple companies offer parabolic flights many times throughout the year. So low cost, quick option as well for research campaigns. This third image you see is a sounding rocket, provides a longer duration of microgravity, 5, 10 plus minutes, depending on the altitude that the sounding rocket is going to. Typically, your payload would also need to be able to handle higher loads for the launch. So it does require probably more time spent on the build and analysis of the payload before flight. But again, a great option. Multiple government agencies offer sounding rockets through their programs. They aren't flown as often as you would probably see a drop tower or a parabolic flight campaign, but an option, especially if you need a longer duration microgravity time for your research. The next vehicle commonly used is a suborbital vehicle. The one you see here is Spaceship Two that Virgin Galactic operates, but there are other vehicles such as Blue Origin's New Shepard rocket that fly microgravity payloads as well. These vehicles are not yet as accessible as the previous I talked about. However, as both Virgin Galactic and Blue Origin move to commercial operations, you'll see multiple flights a year, and it will become much more easily accessible and require a very short lead time leading up to a flight on a suborbital vehicle. A suborbital vehicle provides around 3 to 4 minutes of uninterrupted microgravity time and requires less acceleration forces that you might see on a sounding rocket. So there's pros and cons depending on what you need for your research. One unique item I'll probably note and talk about a little bit later on the suborbital side is that it allows for human-tended research. So you can have a researcher accompany their payload to space and interact with it during the flight, which I think is going to open up a whole new area for microgravity utilization. And of course, on-orbit platforms such as the International Space Station offers unprecedented amounts of time in microgravity, months longer. It is harder to access in terms of the lead time it requires and the analysis work that you'll have to do to go to ISS, but there are multiple resources. The program that we're talking about right now with the UN, the associations that you'll hear presentations from, all provide resources to help make the process for ISS and other on-orbit platforms much smoother moving forward. And then finally, let me just mention that you can utilize some of these platforms for both hypergravity and microgravity, and the parabolic aircraft is one of them. You can have a hypergravity, around 2G section of the flight, as well as a microgravity portion of the flight. I've seen multiple research teams utilize this, and they are utilize both microgravity and hypergravity portions to conduct their research. One that comes to mind, if I to give an example, I believe it's a team from Switzerland and Germany. They were looking at basically the lumbar, looking at lumbar support, lumbar motor skills on the hypergravity, microgravity flight campaign. Astronauts that have spent an extended amount of time in microgravity have noted lower back pain. Actually, regardless of being an astronaut or not, I think all of us, as we age, I've slept on the wrong side of my bed and have had lower back pain, so I completely support this research. But the teams were looking at the effects of hypergravity and microgravity, collecting data on lumbar motor skills and stiffness. So if anyone's interested, I could link that study into the chat. But just a great example of a team utilizing both portions of the platform for their research. And then Hazuki mentioned this. I actually wanted to talk about this a little bit more. I thought this was a really great example of a team utilizing the hypergravity environment for research. This is the team that Hazuki mentioned earlier from Thailand, and they're looking at water meal and assessing its usefulness as a source of food, as a source of oxygen for future space-based exploration, deep space exploration. Watermeal is, I think, the smallest flowering plant on Earth and is very high in protein. So it's a very interesting topic to take a look at. So definitely looking forward to the results of this, this campaign. And then I'll end with some microgravity examples. And all of these are suborbital examples. Because I am a little biased to the suborbital side. That's where my expertise is. But just wanted to mention a few payloads that we've flown on Spaceship Two. Just starting with, you can see on the very left, a payload by the Johns Hopkins Applied Physics Lab. They were testing actually a suite of sensors that characterize our cabin environment during both the high G portions and low G portions of our flight. They're testing out the technology, so when it's going on a much longer duration flight, they have confidence that it's going to work. The ultimate goal for this research is to get data on a portion of the atmosphere where we don't actually have a lot of data. It's a portion of the atmosphere that is too low for satellites to collect samples and too high for high altitude balloons. So Dr. Smith here is looking at a sensor suite to collect data there. This platform, or this payload here in the middle, you can see the silver box. Hopefully, if you guys can see my cursor, I am circling it. It's a payload that is looking at the dispersion of regolith in microgravity. So during the microgravity portion of flight, this payload will shoot a quartz marble into the regolith and observe the dispersion of that regolith. And the applications for this primarily are for future exploration where we're landing on another body, especially maybe bodies we don't know the composition of the regolith, and looking at how we can better protect some of our landers and our critical systems from the dust, basically, that is kicked up from the landing. And then one more I'll mention here is Dr. Annalisa Paul. She flew Arabidopsis plants that expressed certain genes during both the high G and low G portions of flight, looking to create plants that can more readily and easily grow in extreme environments, whether that's on space or on Earth. So very exciting work, and looking forward to seeing a lot more. And the last thing I'll say is this human-tended research capability. This is just it's just a passion of mine. Obviously, on orbit, there are opportunities to do human-tended research through the astronauts that are on station. On parabolic flights, there's the opportunity to do human-tended research by going on the aircraft yourself. But now with suborbital vehicles coming online, there's the ability to do human-tended research in space. So now researchers can fly with their experiments to space and back. And it can open up doors for increased physiological research, and also multiple areas where it's much more difficult to have an external party do the work that you may be very intimately knowledgeable about. So an area I'm super excited about, could probably talk another 30 minutes, but happy to answer questions. And hopefully this provided a good overview of what's out there, what can be done. And I know as we go through the webinar series, you'll get deep dives in each of those areas. And a lot of those researchers have utilized multiple platforms and can talk about more deeply the use for their specific field of research. And the association presentations that are coming up right after me are another great resource to be able to get access to resources, experts in these fields to ask questions. So with that, I will hopefully stop sharing again. Oh, there we go. And happy to take any questions at the end.
Yeah, thank you, Ms. Bandla. It was very excellent. Yeah, excellent presentation. So thank you for sharing your this knowledge and examples and experience with us. Next, I will invite American Society of Gravitational and Space Research to give us an introduction of activity of ASGSR. But due to the different time zones, they cannot join us at the moment. So we will play their pre-recorded video. Okay, thank you, Hazuki.
Greetings from the American Society for Gravitational and Space Research. I'm Gale Allen. I'm the Executive Director of the Society. And thank you for inviting us to speak about the Society at your meeting today. The ASGSR was founded in 1984 as a 501c6 in the United States, which is a nonprofit organization, and it was representing the areas of biology and physical sciences. It is intended to provide a forum to foster research, education, and professional development across multidisciplinary fields, and to bring together a diverse group of scientists and engineers to encourage an exchange of ideas bridging basic and applied biological physical sciences. And the Society is devoted to furthering the field of gravitational research, specifically in how living organisms and physical systems respond to gravity. The vision of the Society is to advance biological and physical sciences research in, of, and for space by bringing together professional communities spanning gravitational biology, radiation biology, physical sciences, bioastronautics, and astrobiology, and mentoring the future scientific and engineering leaders in the field. And I want to emphasize mentoring because the Society focuses heavily on educating students about the research in these fields. We encourage graduate, undergraduate poster sessions at our annual conference, as well as middle school and high school participation with poster sessions. The Society is led by the Executive Director, President, which is a one-year term, the President-elect, the past President, who's following year after the presidency, is chairing the technical program for the annual conference, and our student president. We have a governing board that consists of industry, academia, and the government, and it is the group that drives and leads the direction of the Society. So the board provides the leadership and vision, and the executive director executes those decisions. The ASGSR also has an electronic journal for gravitational space research. It publishes quality peer-reviewed manuscripts in categories of both life and physical sciences. And also it is has been indexed so that it gives you impact data on the value of that particular article in each of the journals. We also created in 2019, the fall of 2019, a companion foundation to the Society. It's the ASGSR Science, Technology, Engineering, Arts, and Math Foundation, which is a 501c3 here in the United States. It was formed in 2019, as I said, and we have 5-member governing board for that society. The difference in the 501c3 and the 501c6, which is the Society, is that in the C3, we can actually accept tax-deductible donations, meaning that the donors can deduct the donations from their taxes, their annual federal taxes, which is of a real value to being able to encourage people to donate to the foundation. We use the foundation funds for specific areas. Right now, we are focused on a Ken Souza Award, which is in collaboration with Blue Origin. Here, a student that wins can actually fly their experiment on one of the Blue Origin's flights. We have a Thor Halstead grant, which is also provides funding to a student, a promising student that has demonstrated leadership in the community. And then finally, we have a new Inspiration Award, which is meant for high school students, giving folks, kids that would not necessarily have an opportunity to participate in these areas of research to get an award, to receive an award from ASGSR to be able to participate with the society as well as during the annual conference. And we also have one funded innovation award in collaboration with Axiom Space. That innovation award is primarily based on finding innovative ways to translate the basic research that is being performed by the scientists in the society to more applied uses. One of the things that the ASGSR has been focused on for the last several months is leading the effort in this community, biology, physical sciences, for a decadal survey. For NASA, a decadal survey, which is conducted by the national academies, is what is their roadmap, their driving force on this research that they will be performing over the next 10 years. So what it does, the study takes the community's input and really focuses and prioritizes the research that the community thinks that is the most important for this area of research. Last fall, we had multiple town halls where we brought people together to discuss what ifs based on what research do they envision 10 years from now, what will be needed, where are the gaps. We've assimilated that information now, and beginning the end of this month in May, we will be condensing it down into what we call microlabs, or bi-microlabs, which will be focusing individual ideas, trying to combine them to get a larger view of a bigger research campaign in particular science areas that are interest to the community. What this will do is then spearhead an output of white papers or concept papers that will be submitted to the national academies as input and consideration for the content that goes into the decadal study. So as I mentioned, we have an annual conference. Last year, we had to go virtual as well as many did, but from November 5th and 6th, we held a virtual conference. If you're interested in any of the recordings, they're still online. You see the website. The plenaries were live streams with Q&A. We had breakout sections, which were conducted by Zoom. Had technical sessions, which we actually pre-recorded. We had 287 member submissions for abstracts and 125 virtual talks, 38 undergraduate, 62 graduate lightning presentations, which were very interesting. We also are interested in keeping the art in this, so we continue to have an art competition. And the images that you see on this slide are actually winners from the art competition that we held last year. We had 544 registered participants and over 100 students, which brings me to just mention that we have about 400 members in ASGSR. We have a nearly 4,000 person database that we can reach out across the community. So this year, we're hoping to be face-to-face. It's planned for November 3 through 6 in the fall at the Hilton Inner Harbor, Baltimore in Maryland in the US. We'll have pre-conference workshops. We plan to have plenaries. We have technical breakout sessions. Abstract call is out now, and the abstracts are due June 1st. I encourage any of you to submit an abstract. We do accept international abstracts. We'll have undergraduate and graduate participation and presentations, and then, like I mentioned, We really encourage middle and high school poster sessions, as well as the art competition. So that's a little bit about ASGSR, and we hope to see you there in Baltimore, Maryland, November 3 through 6. And thank you for the opportunity.
Hi, my name is Elizabeth Talburt. I am the current ASGSR Student Board President, and today I would like to share a little bit about our organization and what we do. We are a student organization with members who are undergraduate students, graduate students, or recently graduated. We focus mainly on career building, educational opportunities, spaceflight competitions, and political advocacy. In terms of career building, educational resources, and access to spaceflight competitions, our monthly newsletter and our bi-monthly webinars are great resources for these. In our interactive webinars, we host industry professionals and academic leaders in a 1-hour interactive setting. The first 45 minutes is a presentation, and the last 15 is a Q&A session. And this is a great opportunity for students to ask industry professionals about their research or even about their career, and gain insight on what student might want to pursue for their career and what options there are out there, and what work and research is currently being produced. For our student newsletter, one thing that we really wanted to encapsulate in this newsletter is having one spot to start. So a lot of people ask, who are interested in the spaceflight industry, where do I start? I don't know where to start. So we've curated internship opportunities, scholarship, fellowship opportunities, and webinars, not just from our organization, but from other spaceflight and professional organizations as well, in this newsletter to give a launch point for students who are interested in the spaceflight industry. Our upcoming webinar is actually about the Ken Souza Spaceflight Competition, which is a competition hosted by ASGSR in partnership with Blue Origin. The winners of this competition are awarded a $1,000 stipend and the opportunity to build their experiment and have it fly on the New Shepard suborbital rocket. So again, it's a great career opportunity for students as well as an educational opportunity, and a wonderful starting point for those that are interested in either experimental design or payload hardware. And it gives a good starting point for students because spaceflight experiments are expensive, and this is a great way to provide access to student communities. In terms of our conference, we have networking events at the annual ASGSR conference, and it also gives students the opportunity to present their work in a professional setting. So we highly recommend students submit abstracts to the ASGSR annual conference. It's a great way to meet industry professionals and also get feedback on your own research. The people that are judging the poster competition are industry professionals or researchers, and they can provide insight on or feedback on experimental design and how you presented information. So again, it's a great career opportunity to get that exposure to what it's like to present in a professional setting and in an academic setting. Additionally, at the conference, it's great for students to attend the talks and the workshops to get an idea of what's going on in the industry right now outside of the classroom, and gain insight on what's being researched and what are the overall larger themes of research in the spaceflight industry. For our political advocacy, the student board goes on an annual trip to Washington, D.C. This year we had our trip. We didn't have our trip. We scheduled meetings virtually. And we meet with congressional staff and discuss the importance of spaceflight research, how it's impacted our career and how we anticipate that it'll impact our career in the future, and why it's so important to fund spaceflight, life and physical sciences research. For those who are interested in getting a little more involved with ASGSR or who want to stay connected to the network, we have the Student and Early Career Associates program. So this program, if you're a recent graduate, maybe a gap year student, or even a current student, you can apply for this program where we require the SICA applicants to engage in outreach, attend the conference and work with the student board at the conference, and also do a diversity and inclusion training module. And all of these are important to our association, and we wanted a way for people who wanted to get a little bit more involved to do so. So we've had some people who are SICA, who are in the SICA program, do outreach to their local universities, but also to Boy Scout troops and Girl Scout troops. It's a great way to engage the community. So in summary, the ASGSR student board is focused on career building, educational opportunities, access to spaceflight competitions, and political advocacy. I hope after this presentation, some of you are interested in joining, and I hope to meet you soon. Thank you.
Okay, we thank the video from the ASGSR, and I'm sorry we cannot answer the questions to ASGSR today. But if you're interested to their activities and the conference in Baltimore, we have already put the links in the chat box. And also, I have to mention that both ASGSR and also the ELGRA. They have a lot of interesting events and also webinars. So if you're interested, please check their website to see the more information. And also, okay, next I will invite Dr. Ricard González-Cinca to give us an introduction on activities of European Low Gravity Research Association, ELGRA, sorry. He is the president at the European Low Gravity Research Association and associate professor at Catalonia University of Polytechnic, and also the director of the Space Exploration Lab of UPC. And he will give us the introduction with the sorry. Yes. So please, Dr. González, the floor is yours.
Good afternoon, or hello. Thank you for the introduction. I assume that you can see my presentation. Can you see it?
Yes, we can. Yes, okay. We can see your presentation.
Okay, thank you very much. So, yes, I'm Ricard González-Cinca. I'm going to introduce you the European Low Gravity Research Association. And in this same presentation, Jérémy and Rabineau will present you our student branch, which is called ELGRA. Our association was founded, sorry about that, I lost the, yeah. Our association was founded in 1971. We're a bit more than 40 years old. And this came from the idea of a group of scientists from different countries in Europe. And the idea or the goal was to form an association which could foster the cooperation and coordination between them, between these researchers, and in general between European researchers, and to provide the ground-based expert advisory service for gravity, low gravity, hypergravity experiments. Currently, our association has more than 150 regular members, 6 corporate members, and more than 260 students. So which is the difference between a regular member and a student member? Mainly student members are those who are up to the PhD level. So undergraduate, PhD students are members of our student branch, ELGRA, while as soon as they hold a PhD degree, they can become regular members. So what is ELGRA? What is the European Low Gravity Research Association? We are a non-profit international society of multidisciplinary character. We are mainly devoted to the promotion of research in Europe in microgravity, model gravity, and hypergravity conditions. And we are basically a platform for all scientists who are interested in both life science and physical science in space. So we aim at representing and strengthening the scientific community of altered gravity research, and also, and this is one of the reasons why we have our student branch, to involve young people in space research by means of educational programs. So what is gravity-related research? I'm not going to discover anything after the nice presentation of our colleague Jack van Loon. Here, just I briefly list different topics of microgravity or hypergravity research that in which our members are involved, like such as fluid physics, material science, combustion, human physiology, space analogs, cell biology, plant biology, etc., etc., etc. So many of our members are very active in all of these fields at the international level. So our management committee is composed of 7 members. The management committee is renewed every 2 years. This year, September this year, we will renew the management committee. And in our management committee, members have different type of backgrounds, I would say. Some come from the life science, others come from physical science, others are more involved in technology development. And as you can see here, well, we don't have the nationalities, but we always try to have a very diverse, diversified nationalities. So every one of our members come from a different European country. So who are the ELGRA members? And which are the activities of ELGRA, or what does ELGRA do in order to promote the activities of our members and help them in their research? So our members are of 2 types, as I said. I say regular members, who are basically individuals who are engaged in scientific research under altered gravity conditions. And we also have what we call corporate members, or which are mainly scientific institutions or companies with interest in altered gravity research. So what do we do? What does ELGRA do for our members? So we cooperate with institutions and agencies, space agencies or agencies in general, in the organization of scientific events. An example is this presentation that we're giving today in this workshop. We also spread information about announcement of opportunities of space agencies or other institutions to our members. We inform them about any new platforms that could be available to them, and in general, space policy that could be of interest to our members. We also organize scientific symposia and courses. Here I would highlight 2 of them. We have a biannual ELGRA symposium, which gather not only our members, but also researchers from all over the world who are interested in microgravity research, to present their work and to discuss with the attendees to the symposium. We also organize courses. In particular, we organize a summer school together with the European Space Agency. We have already organized 4 editions. We're going to organize this year the 5th edition. It's an annual summer school, which is addressed to undergraduate students with the aim to introduce them to low gravity and hypergravity research. So it used to be 1 week intense summer school. Now we extended it to 2 weeks. Last year and this year are virtual, but we hope that probably next year we can come back to on-site edition where students are meet in the ESA facilities in Redieu in Belgium. So we also support our members with research grants, for example, the ELGRA Prize, which is addressed to early career researchers. The aim is to help them to somehow become independent of the research group with new ideas so that they can start or they can start their own individual career. We also support our members with access to microgravity platforms. And this is why we created what we call the ELGRA Go Suborbital Call. This we have organized it in collaboration in the first edition with the Swedish Space Corporation, and in the second edition with Blue Origin. And basically what we aim is, or what we provide our members is the opportunity to fly a payload in a suborbital flight, in the first edition with a Swedish vehicle, and in the second edition with a Blue Origin vehicle. Also, we support our students, or in general students, as you will hear from Jérémy, and we collaborate with ESA education programs, Fly Your Thesis, Spin Your Thesis, Drop Your Thesis, which you will probably hear of in this workshop. As I said, we organize a biennial symposium. In principle, we would have liked to organize it this year. The last one was 2019 in Granada, in Spain, and we plan to organize this year in September 2021 in Lisbon. However, given the current health situation in Europe, we have postponed it to 2022. I'm not sure yet whether in spring or fall. So if you are interested, you will see information about it in our website. In our symposium, we always have a special ceremony, which is the ELGRA Medal ceremony. The ELGRA Medal is an award given to an ELGRA member for two ELGRA members, one life science, one physical science, for their exceptional services to the community and or to outstanding scientists in the field of microgravity, life science, or physical science, or technology. Communication is very important to us. We are in contact with ESA and other European national agencies in order to exchange information. We're also in contact with our partner scientific associations in the US, ASGSR, or in Japan, JASMA. We present the ELGRA activities in conferences and other contexts, like in this workshop today. We are happy to help our members, either individual or corporate members, in the European Union programs. And finally, we also have Facebook and LinkedIn groups. In communications, at the end of our symposium, there is always a special edition of the journal Microgravity, Science and Technology. We also have a biannual newsletter, which used to be a biannual magazine, which used to be a newsletter where we describe all the activities carried out in our association for the last year and a half. And we also are happy to collaborate with our members in the edition of books, like the book that you can see in the image that was edited by Jacques van Loon and Daniel Beysans on generation applications of extraterrestrial environments on Earth. So if you would like to have more information about our association, you can obviously contact me by email, or you can have a look at our website that you can read here. So now I hand the floor to Jérémy.
Okay, can you hear me? Yeah. Thank you, Ricard. So yeah, my name is Jérémy Rabineau, and beside being PhD student in space physiology. I'm also the president of the student chapter of ELGRA, so ELGRA. And as you can see on the map here of the student of ELGRA, we are open not only to European students, but also to students from all over the world, just like ELGRA is open also to other countries as well. And as you can see, we still have a lot of countries to fill. So if you are in one of these countries, I also encourage you to apply, since the membership is for students. Can we go to the next slide, Ricard? So yeah, this is maybe not very simple, but we have a committee of 6 members from all over Europe. The next slide. Okay, and so as has been mentioned so far, so outer gravity is in fact many different fields, and we have also members from different fields. Here is, for instance, an example with physiology, or with here the spine, elongation of the spine in space. Next slide. And we also have and we also have students involved in human performance, others involved in physical science, in actually all the different fields that have been presented so far. Next slide, please. Okay, the aim of ELGRA is to be a network of students interested in the same field, the field of gravity-related research. So to help the students in this field, we are communicating a lot about the different opportunities that can appear in this field, about summer schools, about internships, PhD opportunities, etc., etc. Maybe you can go to the next slide, please. More concretely, let's imagine, for instance, that at the end of this webinar series, you are very interested to do, for instance, an experiment about biology in outer gravity. You want to apply to a call by the UN, or a call by ESA, or any organization you can imagine. But maybe you are the only one in your university that is interested in this field. And maybe you need to find other team members to help you and apply for these opportunities. That's something you can do with us. For instance, we have a Facebook page. You can just come and say, yeah, I'm a biologist in this field. I would like to apply. I have this idea, but I need an engineer to help me build the experimental setup. I need another biologist to help me in these other aspects. And then let's build a team together and apply. So then once you do it, hopefully you're selected, you're doing your experiments. And the other step of the process where we would like to help you is afterwards, when you want to present your experiments, for instance, at scientific conferences. So usually in normal years, which is years without COVID, we launched call for grants to help the students to present their research in scientific conferences. Maybe next slide. So these examples are before the COVID era, 2018 and 19. These are some examples of the conferences we have been to, and we have helped people to go. So hopefully we can open these call for grants in the very near future. Next slide, please. Okay, and one of the last opportunities that we opened to students is to take part in zero-G experiments with a startup called Light, doing parabolic flights with a glider. And we have recently selected a team of Portuguese students so that they will be able to perform their own experiment on this platform. Next slide, please. So yeah, we are very active on social media. Here is a list. You can find us quite easily on this social media. We also have a newsletter where we share articles written by our students about their activities, their personal experience of microgravity research or hypergravity research. We also share all the news about the field, whether it is new opportunities, new PhD offers, etc., etc. We also have webinars that you can see on the right, the great Jack van Loon doing our first webinar. And we also gather at different scientific conferences, mainly in Europe. Next slide, please. I think it's the last one. Yeah, and this is the last one. So thank you very much.
Yes, thank you, Jérémy, and also thank you, Dr. González. I saw that there are already very good questions in the chat box, so we will answer all the questions later. And please catch this opportunity if you have any questions or any comments to us, to ELGRA, to SELGRA, and also to Dr. Jack. So okay, so next I will invite the last speaker of today's webinar, Dr. Osamu Fujita, to give us an introduction to Japan Society of Microgravity Science and Application, JASMA. Dr. Osamu Fujita is a professor at the Division of Mechanical and Aerospace Engineering at Hokkaido University. He is also former president of JASMA. Okay, Dr. Fujita's floor is yours.
Okay, thank you very much for a nice introduction. Can you hear me?
Yes, I can hear you, and I can see the presentation well.
Okay. So today I introduced the Japanese Japan Society for Microgravity Science and Application, in short, JASMA. This is the community of microgravity researchers. This is the brief description of the JASMA. The Japan Society of Microgravity Application has been established in 1983 to provide a platform for academic exchange of microgravity science and technologies. JASMA covers fluid science, crystal growth, physical chemistry, material science, combustion, biological science, under microgravity for space utilization. The membership is about 200, mainly from academia, space agency, and industries in Japan. And this is the statistics of membership, and the regular member 147 and the students 47, and the advisors and the company members. And our main activities are listed here. The main event is the annual national meeting, JASMA conference. And in the event, we provide the JASMA prize and student poster session. I will explain more about this later. And the also the another function is the we works as the platform to propose a new subject or new theme to JAXA, and also we also have a research grant. Also, we have our own journal, academic journal, which is called as IJMSA, International Journal of Microgravity Science and Application. And also, we organize international meetings like ISPS or AMS, Asian Microgravity Symposium. So this is the introduction of the last our annual meeting called as a JASMAC, and it was held in 2020 in October, and that is a 32nd term. There are how many papers presented in the symposium is the total is 73. The regular presentation or organized session, poster presentation mainly for students, and invited lectures, and the awards, JASMA awards lecture. And the area is the material science and fluid science, combustion, life science, and thermal properties, and this is the fundamentals for moon-based research and other type of research. That includes the presentation from high school and also some companies' presentations. So the period of the symposium was for 3 days. In this case, the from October 5th through October 7th. Okay, so one of the unique part of this annual meeting is Mori poster session. Mori poster session is an event to encourage students in the field of microgravity science. And Dr. Mamoru Mori here is the first Japanese astronaut who has carried out space mission called as FMPT in 1992 on STS-47. He has another flight at STS-99, so he has experienced 2 space shuttle flights. And in this event, Dr. Mori talks to individual students on their research in the poster session and encourage them for their research. So this program is very popular from students, and generally we have a lot of students to present in the poster session. And we choose some poster presentation as the best poster award, and Dr. Mori presents best poster award to encourage young generations. But the last year, the meeting was online, so those events were held online. This is some pictures of the Mori poster sessions, and all students are very excited to present their contribution to astronaut, and that's a very, very extraordinary experience for them. And this is the awarding ceremony, and some students are selected as the best paper award, and as a extra prize, they have the students can get something. In this case, this is a T-shirt of the STS-99. This is the flight which Dr. Mori has taken, and with his signature, and present this extra prize to all students. They look very happy, and it's a very good event to encourage young generations. Also, in the last annual meeting, we have got many invited talks. Generally, it's very difficult to have such precious talks, but last year the meeting was online, so we have got the presentation from ELGRA, Ricard. He has just presented as the introduction by ELGRA, and also the presentation from ASGSR, Dr. Douglas Matson, the former president of ASGSR, and also the presentation from DLR to present the state of art of the DLR activities by Dr. Andres Meyer, and also from Korean Microgravity Society, Dr. Ji Hyuk Choi, to present, to introduce the activities. And the last one is from China, the China Microgravity Community President, Dr. Jiang Fu Cao. So we have 5 invited presentation in the symposium. I introduce our academic journal, which is called as International Journal of Microgravity Science and Application, IJMSA. This journal is an academic journal published by JASMA, and it is an open access journal, and 4 issues are released every year. And the journal has an ESCI status, and citation data for the journal are formally recorded in the database of Web of Science. So we sincerely welcome submission of papers from all over the world. In 2018, we published 33 full papers in the journal, and in 2020, full papers. So please go to this website to see how it works, and especially this journal is very helpful to grasp a whole view of Japanese microgravity research activities. Okay, so there I introduced some microgravity facility available in Japan. One is the drop tower, which is called as a Cosmotore. As you may know, we have ever had a very big drop tower called as JAMIC. This locates in Hokkaido northern island of Japan, and drop length was 500. But unfortunately, it is closed in 2003. And another drop tower, MG Lab, which had the drop length of 110, it also terminated in 2010. And now this is the biggest drop tower in Japan, and it drop length is 50 meter, and the microgravity time is around 3 seconds. Another facility is the parabolic flight provided by Diamond Air Service, and this is the airplane of MU300, a very small airplane. So it's the number of passengers is very limited. So we can ask the company to provide their gravity condition whichever we like. And International Space Station and Japanese module Kibo right here, and its construction has finished in 2009 July. And I introduced some ISS utilization project. Sorry, this is in Japanese, but my intention, I intend to show how many projects has finished and ongoing. And these lists are limited to physical science, not life sciences are not included. But the top left corner is material science, and the combustion and boiling or two-phase flow or heat transfer. And the top right corner is the crystal growth, and fluid dynamics. Middle is fluid dynamics, and space technologies. If you want to see more about project using Japanese International Space Station by Japanese researcher, you can go to this website. And our the recent interest is the of course the Artemis program. The community member in Japan are looking for the topic how we contribute to this program. In this program, many situations are included, like transportation from the Earth to Moon, and the access from the orbit of Moon to the Moon surface and the Moon base, and go further. So in this process, a lot of situations are included, like varied gravity, or the inside the spacecraft or inside the Moon base, the oxygen concentration, pressure, or many conditions are different. And I introduced, pick up one topic. This is the topic I'm involved in. And this topic is fire safety research for space. And the project name is called as a FLARE project. And in this project, we are aiming at building up a new fire safety standard. So this is the logo of the project, and a lot of this is mainly led by JAXA, and JAXA is working with NASA or ESA, CNES, DLR, or many universities. Why we are working on building up a new fire safety standard is the material flammability is very different between normal gravity and the microgravity. One of the main cause of fire in space is electric fire, and typically the short circuit is the of the short circuiting of electric wire in normal gravity. And under the completely same condition, but the only gravity condition is as you can see, the ignition easily happens. So it implies that the flammability is enhanced in microgravity. And this is, I don't talk much about that, but this is the ignition limit in normal gravity, but this limit extends a lot in microgravity. So this discrepancy is necessary to consider when we build up new fire safety standards. And another example is the this. Can tell the flammability is apparently higher in microgravity under some given condition. This is the extension of a flammability limit. So the to consider the fire safety standard, we need to include such extended flammability in our fire safety standard. So the target is the to develop such new fire safety standard counting such gravity effect. Then this is the established method, and such estimation based on newly established method is compared with the space experiments on in ISS, and also the previous results taken by NASA. This is the one picture in the International Space Station, and he is the astronaut Noguchi-san with the flaring. This is our experimental hardware on board right now, and we are just starting these experiments now. This is inside the keyboard module, okay? And this is team members, and we are closely working with the European or American, or they all over the member all over the world. Okay, so we are happy to work with the International Microgravity Community, and please contact us. Here is the our website. Okay, thank you very much.
Thank you very much, Dr. Fujita. And before we go to the question and answer, and I would like to mention it again, and to improve our performance in the webinars and also provide us with more ideas about future webinars, please make sure to fill our questionnaire form before leaving this meeting room. The link is already there, and it will take only a few minutes, and it will help us a lot. And also, please make sure to register in our following webinars. The registration link is in the chat box also. And this time, you can subscribe to next 8 webinars. So, okay, so let's do the questions. I hope Dr. Wallon and Dr. Fujita and Dr. González, you're ready for the questions?
Yeah, I'm in.
Yes.
Okay, perfect.
Okay.
So let's see the first question. Yeah, the first question is from Charlie. When can we expect the Dream Chaser or China Space Station experiments to actually happen? I think my colleague already answered it in the chat box. So I will just mention that we hope to open the Dream Chaser opportunity as soon as possible. And for China Space Station, there's 9 projects selected last year. So as I know, the China Space Station is building, and the core capsule is hoped to launch this year. So I would say that it may happen in next 2 or 3 years. Okay, so we move to next question.
If I may add about the Chinese space station, as Wenbin said, currently we're still developing the projects that have been selected last year. So as Wenbin said, in the next 2 or 3 years, we hope maybe next year or in 2 years, we hope to open a new opportunity, a new selection. We are in discussion with our partners. So we'll definitely keep you updated. We'll keep everything updated on the website. So please check our website for updates about the opportunities.
Yeah, sure. Thank you, Hazuki. And the next question is from Matt Haven. He asking, and is that dangerous to play with fire in space? I just saw that Dr. Fujita, you explained a little bit in your presentation, so maybe you can answer this question. Is that dangerous to play with fire in space?
The question is the fire in spacecraft is dangerous. Is it the question?
Yes, I think so.
Oh yeah, of course. The very serious problem, and once a fire happens, no one cannot help you. Fire engine never come. So the we completely reduce the risk of fire 0. So that's a very serious issues. And I think the main or most major cause of fire is the electric system. Because the on the ground there are many type of cause of fire, like smoking or child fire play or kitchen fire. But yes, those cause of fire never happens. So the we ban the risk of electric fire is the main target to reduce the fire risk. Thank you.
Thank you, Dr. Fujita. And Dr. Van Loon.
Yeah, I also think the question was asking about how experiments regarding fire were tested. So I think the question was that it's dangerous to do it in the International Space Station. So maybe you're doing it on the ground or using different platforms. So maybe you can elaborate on how you're testing the fire-related experiments.
So the yes, combustion experiment is already dangerous to do in space stations. So the we always be very careful to do the combustion experiments in space. And sometimes, yes. So the of course there we make many repeated experiments on the ground and completely build up the experimental system to avoid all of the risk of fire, even for the combustion experimental setup. I'm not sure this is the answer for you.
Yes, thank you. I don't think if Dr. Vallon, you have something to add to this question.
No, I mean, we heard the experts. I don't have anything to add here. Thank you.
Okay. Okay, so we move to next question. Next question is from Giuseppe. He asked, how does microgravity affect plants' growth?
Well, if I can get you some aspects here, what you do see, you know, what I
Dr. Van
explained
can
earlier.
answer this question.
Sorry? Yes. Plant growth under microgravity is not trivial. I have one slide on that because the way the fluid has to be presented to the roots, for instance, or the external environment on the air, let's say around the stems and the leaves and the flowers, needs to be refreshed. So plants will hardly grow under real microgravity conditions, especially you know, larger plants. Small plants is possible because you still have diffusion there that might work. What you see also, and that is also done with experiments we did in the past with the late Mary Musgrave. She was the first who did a full plant cycle, so from seed to seed under microgravity conditions. It is possible, but you have less seed production under microgravity conditions as you compare that to normal G conditions. And also under hypergravity conditions, you see differences in the seed productions of these plants. But it is possible to grow plants under under microgravity conditions with a well-engineered facility for that.
Yes. Mr. Giuseppe, Mr. or Mrs. Giuseppe, I hope Dr. Van Loon answered your question. And also we have a biology webinar, so it will happen next week. So yeah, please make sure to register in our following webinars. Okay, so I will move to next question. It's from Sagar. He or she asked, which parameters should be taken into account while selecting different microgravity experimental facilities, and how to calculate the response time of biological systems? Okay, I will first address this question to Dr. Van Loon.
Yeah. Okay. Yeah. First, you have to, if you want to work with gravity and see what the effect is on your system, indeed, you have to have a good knowledge of how your system responds, also with respect to time, and also with respect to the sensitivity of your system. If you go to microgravity or micro weight, one of the best facilities would be a drop tower, and especially the one in Zarm is very good on that. You also have one at NASA Glenn in the US, because these microgravity conditions are very, very clean. 10 to the minus 5, 10 to the minus 6 G is very good. And then, of course, you have the International Space Station, although there you also might have environmental disturbances, sometimes in experiments you do not want. Then, let's say the less one is the parabolic flight, also again, because you have atmospheric changes due to these parabola. So you not always have a very perfect microgravity condition. So that's the low G part of it. The high G part in centrifuges, yeah, I mean, you can isolate your experiment and have a very clean hypergravity environment, but it's they always have moving systems, so there's always disturbances and vibrations in there. And in terms of time, yeah, we didn't have the time to go into it, but I think there's some more explanation of the various platforms later in the series of webinars. But you know, drop towers in the series in the frame of 5-10 seconds, parabolic flights, you know, 10-20 seconds, and then you have the free flyers, weeks or days. You have the suborbital, which is in the order of minutes. So it depends a bit what your experiment needs and which one of the platforms you can use. But if you can make use of the ground-based facilities, so either you know, clinostats or RPMs or even magnets sometimes, try to make use of it and then take the next step, a parabolic flight, before you go for real, you know, sounding rockets or free flyer conditions.
Yes, and for which parameters should be taken into account while selecting different microgravity experiment facilities? I would ask Dr. González if you have any other issues could share with us.
You're muted.
Ricard, you're muted.
Sorry about that. Okay, start again. Yeah, actually, I fully agree with what Jack said. Basically, first of all, what you have to do is to master very well your experiment in the lab, so that you have to be able to predict which are going to be the main parameters that you will use. And in particular, you have to be able to predict which is going to be the microgravity time that you will need in your experiment. Either a short microgravity time, which is what is provided to you in the drop tower, or a very long microgravity time, which you can achieve in the ISS, for example. Second, you have to be sure what is the microgravity level that your experiment requires. Again, drop tower and ISS provide you with the best microgravity level. Parabolic flights, they provide you with microgravity conditions, but maybe not such a pure microgravity level. So it will depend on your experiment. I can give you a simple example. In our case, we work with two-phase flows, which is bubbles in space. Just imagine if you have a fizzy water in at home or in a restaurant and you shake it a bit, you will see that you change very much the dynamics of these bubbles. So small changes in the gravity level cause a big impact in the dynamics of these bubbles. So for your bubbles experiment, for your two-phase flow experiments, you require really very pure microgravity conditions. However, in this case, with a very short time, you can see what's happening to the bubbles in its dynamics. So you probably don't need to go to the ISS for these experiments, and you can go to the drop tower, which provides you, in the case of Bremen, 4.7 seconds. And finally, I will point out something very important, which is, okay, apart from a microgravity time, a microgravity level, a very important aspect is your payload, your experimental setup, weight, volume, power consumption. Okay, all platforms are different, and obviously at the ISS you need a very small experimental setup. If you go to a parabolic flight, you can have a much larger volume. So these are the three main aspects that you have to consider.
Okay, thank you, Dr. González. And we will move to next question. It's from Charlie. He or she asked, do RPMs work for crystal growth? I think it refers to the one that Dr. Vallon, you mentioned in your slides, is microgravity facilities. So maybe you can answer this question.
For crystal, I mean, most of these microgravity simulations are used in life sciences. For physical science experiment and ground-based simulations, there have been some experiments that use not an RPM, which is a 3D environment, where you also have, let's say, a forced fluid motion within your system. And this is, of course, what you do not want if you want to do a crystallization experiment in this sense. Or you want to play around to make your fluid more viscous, for instance. That's another way to play around with it. But basically, if you want to do some crystallization of fluid-related experiments simulated on ground, you might think of a 2D simulation, so rotation in a very small environment. There has been done some experiments in the past with colloids and a clinostat sort of setup. Another simulation on ground might be for liquids magnetic levitation, although you also have artifacts there. Well, you have artifacts in every system you use, but also there you might have artifacts in terms of orientation of your materials. But these are the ones that I would recommend. I would not recommend an RPM for fluid and crystallization experiments.
Yes, thank you, Dr. Vallon. And I'm sorry, we are a little bit out of time, so I will answer maybe 2 or 3 more questions. So the next question is to Dr. González. It's from Matt Haven. He asked, is this the Artemis training community? I think Artemis means it refers to the United States the lunar exploration project, and yeah. So Dr. González.
So what's the question again?
The question is, I think he asked, is ELGRA is the Artemis training community?
I think he wants to ask if ELGRA is involved in any of the Artemis programs. I saw that JASMA is taking part in some of the Artemis related programs. So maybe if ELGRA is related to any Artemis program. I think that's the question.
I see, I understand. Okay, ELGRA as an organization is not involved with Artemis. There's no any kind of partnership, etc. But obviously, members of ELGRA, researchers or corporations, they carry out research which is very much related to lunar exploration, in particular Artemis program. So, and basically you have to bear in mind that science in microgravity has a lot of links with exploration in general, not only to the moon, but to Mars and in general to our solar system. So yes, there's an involvement of some of our members, but not officially as by ELGRA as an association.
Okay, good. So it's very clear. So okay, let's see the last question, maybe from Shubham. He asked, what are the similarities in between artificial gravity and gravity, microgravity, hypergravity, and can this help to create a web dive in space? So I think it's a very fundamental question, and I also want to know that. So maybe Dr. Vallon, you can answer this question first.
I'm not very familiar with warp jumps in space, no, I haven't got a clue. I mean, I cannot answer this question. Maybe no, I don't know.
Okay, perfect. Okay, so let's see what questions do we have. Okay, I see a lot of questions. Okay, so if any guests are interested in the membership of microgravity, hypergravity societies. So first I will combine these questions together. It's from Kashish and Luca and Lipist. They are asking, is membership for ASGSR community, and is it possible to apply for ASGSR student opportunity as an international student? Our international students are able to be a member of ASGSR. So first I will handle these questions to Ms. Bandla.
Yeah, I think we actually had the answer pop up in the chat, but just to repeat it, yes, ASGSR memberships are open to international students. And Elizabeth, in her presentation, I just wanted to mentioned the Ken Souza competition for the opportunity to fly a payload on Blue Origin's New Shepard suborbital vehicle, as well as I believe you get a small grant to help with the build, I believe. need to double check. But if you are a ASGSR member and you are an international student, you are available, or you are eligible to participate in that competition. So I'm happy to put a link to that competition in the chat box for the future.
Yeah, okay. Maybe Dr. González, you can introduce something about ELGRA.
You mean the memberships?
Yeah, the membership of the ELGRA.
Yeah, well, as I said, the student association members are students up to PhD level. So after PhD, they will become regular members of the association. And in principle, members can come from any country in the world, although, of course, the majority, they are Europeans, but we have from Asia, from America as well.
Yeah, sure. And I see that we have a friend from ASGSR, Mr. Álvaro Lomio Carvo. He's in the chat. So maybe Mr. Álvaro, you can introduce something from your point of view. You are muted.
Now it should be okay.
Okay, perfect.
Thank you very much. Sorry, Wemi, could you repeat the question, please? I was writing in the chat when you were speaking.
Yeah, just some guests are interested to become a member of ASGSR, and they're both working person like that.
Yes, I mean, if anyone wants to become a member of ASGSR students, I encourage them to apply and send the registration for sure. We have members from around the world, and we have a pretty active community. We have our own Slack channel, webinars, the newsletter, all over social media. We do a lot of activities. We organize many social events. So our activities are not restricted at all, particularly now in the middle of a pandemic, to the US community. So yeah, of course, if you want to apply for ASGSR, you are more than welcome, and you will get access to opportunities like the Ken Sousa competition, whose link Sirisha has just shared in the chat. So feel free to register and join us next Friday for more details on that.
Okay, thank you. And Jérémy, I don't know if you have anything to add.
Yeah, okay, I'm here. No, I mean, I think Ricard mentioned already everything. We are open to members from any country in the world, even though some of our opportunities are reserved for European members or for instance, conference happening in Europe. But everyone is more than welcome. I think we can all learn from each other. Yeah, maybe one thing. So the difference also between the student membership and the regular membership is the price, because for students is absolutely free. So it does not cost you anything to just try and apply and become student members.
Yeah.
Also, may add about the Asian societies. I'm not entirely sure about their membership, but as you can see, they're doing many different activities. Some of them are doing webinars, symposiums, and different events. So please make sure to follow them on their social media, go to their websites, and try to reach out to them too, because I think they have amazing activities going on as well. Thank you.
Sure, thank you everyone. So let's move to next question. The next question is from Nicholas. He asked, is there any recommendations to I saw that Sirisha already answered. And give some answers to this question.
Sorry, maybe Wenbin, the Wi-Fi, there was a bad connection. Maybe if you can repeat the question again.
Yeah, the question is, Is there any recommendations to starting or investigating microgravity combustion? The question is from Nicholas.
I'm probably not the right person to answer. I put a link in for some resources, but perhaps this could be a suggestion to Wenbenyu and Hazuki for future subject matter experts to add to the webinar, because it is a very interesting area for research for microgravity especially, and we saw some of the research being conducted in the very last presentation as well. So.
Thank you, Sirisha. Exactly. We have more webinars coming up about material sciences, and there's fluid dynamics going on there as well, so maybe it can be referred to there. Also, we'll have webinars from the regional activities, so maybe some of the space agencies and the companies in each of the regions might be doing that as well, so make sure to follow all of our webinars to get that answer. Sorry we can't answer it now, but I think there'll be a lot of information coming up soon.
Let's skip to next question. This from Matija. She's asking, do astronauts exhibit any muscular atrophy or problems with motor functions after prolonged stay in the microgravity environments? Maybe I can handle this question to Dr. González.
Yeah, sure. They experience this type of problems. Actually, you can see when they land on Earth, you can see which state they arrive after some months in at the ISS. And actually, this is why they have some equipment in order to make some exercise, some kind of bike. Well, I call it bike. It's not really a bike, but some kind of instrument that helps them exercise their muscles in their body.
Maybe if I may add something to this. We know very well what happens in 0G. We know very well what happens in 1G. So we know that at 0G, things are getting worse. So you lose a lot of muscle mass in the lower limbs. But we still don't know very well what happens in between. So there is a whole lot of levels of gravity, like moon gravity, Mars gravity, where we don't know what happens. And these are also very interesting fields for the future if we want to go to the moon or if we want to go to Mars to see what is going to happen to the next astronauts.
Yeah, sure. So we will have a dedicated webinar, which is webinar number 3, the week after next week. So this webinar will focus on the physiology. So if you want to know more about the human activities in the space, so just to keep tuned into our webinars. So let's go to the next question. Is from Karish. Are these projects able to maintain the global participation in the pandemic? Yeah, maybe Dr. González, you have an answer to this question?
Well, I understand that the question is microgravity research able to help in the fight against the pandemics? I guess this is my interpretation of the question. Yeah, well, yes. I'm not going to say immediately. We're not going to find any immediate solution to the pandemics by carrying out research in microgravity. But it's there is research on viruses in microgravity. It's clear that the microgravity might compromise the immune system, which is very much related to the COVID, and also in the way it spreads in a room while we speak. When we speak and we eject some droplets, this is also interesting to note the effects of gravity in the spread of these droplets around the person who is speaking. So both from a point of view of human physiology or medicine, and also from the point of view of fluid physics, research that is being carried out in microgravity platforms can contribute in the fight against the global pandemic. Yeah.
Okay, Ms. Sirisha, I don't know if you have anything to add.
No, I think the answer, I think that was a really good answer. I think the research, as we discussed, that's being conducted has quite a lot of applications, and one of them is looking at some of the global health issues that are happening around the world, either to right now, which is a big one, or in the future. And I think a lot of the research that we're doing is very fundamental to understanding and reacting to that now and in the future.
And actually, there's one thing very, very interesting, not directly science, but some of the technologies that have been used in space to allow to measure for instance, the cardiovascular function in space. So teleoperated echocardiography. This was, I would say, invented for the use in space, and then it was applied, for instance, in Italy and in different countries, so that non-trained people could do teleoperated echocardiography with experts in another country. And this is very interesting, and this has been used during COVID time.
And if I may add, one of the teams that participated in drop tests, the team from Bolivia actually was doing experiments related to microgravity in the Bremen drop tower, but that team is actually working on ventilators. So the technology that I'm not saying it's directly linking, but the technology, the skills that they achieved through drop tests is helping them to do different things and bring in different applications. So yeah, joining our initiative can help you bring more. One thing can bring you more things. So I just wanted to mention that they're doing an amazing job.
Yeah, yes, thank you both. These answers. I think everyone wants to do their efforts to help to the especially in the pandemic. So okay, we move to next question. Next question is from Daniel. So he asked, how can microgravity research done technology on Earth? Yes, so first, before I handle this question, I have to mention that we have the webinar next week is focusing on the biology. So that webinar would have a many interesting topic on plants or something like that. So please make sure to come back next week. And yeah, for this question, I think maybe I will handle it first to Ms. Sirisha. Should I repeat the question?
I saw it on the chat, so I can take a step. Yeah. So specifically, just looking at the example I gave in my presentation with Dr. Annalisa Paul, who was flying Arabidopsis samples up on our suborbital vehicle. Those plant samples were modified to express certain genes upon being stressed, whether in the 2G or the high G portion or the microgravity portion. And by collecting that kind of data, looking at how plants react to those extreme environments that they are not used to on Earth, we can create plant samples and plants that can more easily be adapted for environments on Earth that are in harsher environments, but also in the future, obviously, for deep space exploration. But Dr. Annalisa Paul is looking at particularly modified plants that express certain genes to collect this data on what is stressing those plants out in these environments that they're not typically used to.
Okay.
Hopefully I answered the right question, but I assumed it was the plant physiology question. Okay.
Okay. Dr. González, if you have anything to add?
I have very few to add in plant biology, believe me. I know that it's very good for traveling to Mars, but I really, if I understood well, the question was on the applications on Earth. But anyway, in general, I would say that microgravity research provides you new understanding on any phenomena on a life science or physical science, and you can learn a lot by removing gravity from the equation, either in a problem on combustion, fluid physics, or in plant biology. So I'm sure this is what researchers in plant biology do.
I think there is a very interesting application. For instance, so in Europe, you have the MELSA project. It's basically trying to work on a bioregenerative system so that you can feed the astronauts and recycle the waste and so on. And one of the application of this is, now we have a better understanding of how we can use the algae, how you can grow vegetables there. And now they are using this directly in Congo to grow algae there, used as a food in Congo.
Yeah, I'll just add, there's just the unfortunate reality that the parts of our world are changing. There's areas of our planet that used to be pretty hospitable for growing that may not be anymore as time moves forward. And some of the work that our researchers are doing are hoping to help create variations of plants that can adapt to some of that change in climate that we're seeing to hopefully continue to provide food security in certain regions. So there are, as we all mentioned, multiple applications to studying how plants react in extreme environments. And unfortunately, there are more and more unusual environments on our planet that we need to adapt to, unfortunately.
Okay, thank you. I think we ran a little bit out of time, so I will have last two questions. Okay, the first one is from Cecilio. He asked, what are your thoughts on performing surgeries and other types of medical procedures in microgravity and hypergravity situations? Yeah, I think it's very interesting because I don't want to see scope holes floating around me. So I don't know, just handle this question to Ms. Sirisha, please.
Yeah, I definitely think it's important if we're going to be doing deep space exploration. We're not going to have access to the hospitals that and all of the amenities that we're used to. So we need to be able to handle events and any mishaps that may happen during that travel. And interestingly enough, actually, I am working with a researcher right now who's working on technology to fly on our vehicle very shortly to handle surgeries in space. And he's working on testing technology and microgravity to be able to do that moving forward.
Okay, so Dr. González, if you have anything to add.
Well, yes, it's clear that it has a lot of interest. Surgery in microgravity, if we want to travel far from the Earth. I'm not sure about surgery in hypergravity. I can't think of when do you want to do surgery in hypergravity conditions. So maybe it can happen sometime, but I could avoid it, not only because it's probably not very easy, but also because I don't really see when would you have the need to do that.
Yeah, okay. Okay, let's go to the last question. It's from Sylvia. He or she is asking, which are your advice to start a career in microgravity research? It's a very good question. So maybe Dr. González, you can have it first.
Well, I think that if, at least in Europe, if you ask too many young researchers in microgravity in Europe, probably many of them have started their interest in microgravity or their activities in microgravity participating in these education programs, fly your thesis, spin your thesis, drop your thesis, etc. Others, I see Alvaro there, started in the summer is ELGRA summer school as well. So at least in Europe, these are two very good opportunities. Obviously, we are talking to people all over the world. I'm not familiar with similar problems in other countries, but worst comes to worst, you can always contact a lab in your country or close to you where they carry out microgravity research, talk to the professor there, and see what you can do. Obviously, you have to have some technical background or scientific background. I mean, but there are many possibilities to have this, and you just need to start working on a PhD, or if you can do it a bit before that. So the difference will be if you start doing microgravity research when you are still an undergraduate or a graduate student. You don't need to wait for the PhD.
Okay, Ms. Sirisha, maybe you can share your experience?
Yeah, absolutely. I'm an engineer by training, so I went through my university, but I think any of the organizations that we just heard presentations about, becoming a member or attending an event is a really good way to get to enter the sector, get to know people, find an area that you're passionate about. So would definitely recommend reaching out to some of those organizations to get more resources. And of course, the reason why we're all here, I think Hazuki has also introduced some opportunities through the UN that could provide an entry into the microgravity and hypergravity research. So just really reach out, talk to experts, attend these webinars, get to know more about what you're really passionate about. And I think that's really a good starting point.
Yeah, thank you for your experience. So I see Arvalo here. You want to ask something?
Yes, I just wanted to support what Ricard just said, because I was one of the lucky guys who participated in the ELGRA Summer School a few years ago. So I just wanted to say this, the way to enter, as Ricard and Sirisha said, is get involved with your organizations, and as soon as possible, no matter how old you are, start doing microgravity research from a practical perspective. So there are many organizations, UNOOSA, ASGSR, ELGRA, JESMA, that offer opportunities to run microgravity experiments. And actually some of them, you don't really need to be a big expert in a field to come up with a scientifically sound experiment. So go ahead, don't be shy, and get involved in this field as soon as you can, if you are really interested.
Yes, and Jérémy, you have anything to add?
Well, I totally agree with that. I mean, there are so many. I mean, the sooner the better. I encourage you to do. And even if you are at university doing something, I encourage you to do other things on the side because this is a very interdisciplinary field. Even if you're doing biology, you'll have to know have some basics of engineering if you want to build your setup to make it flight on a parabolic flight or anything. And so yeah, the sooner the better. There are many organizations, whatever the country you are in, you can still join some of them. There are those that have been presented today, but I think also about the ASGAC, sorry, Space Generation Advisory Council. So many international things. There are the opportunities organized by the UN. So even if you're not from Europe, if you're not from the US, you still have many opportunities that you can apply to.
And if I may add, on behalf of the office, we want to make sure to be the bridge between your needs. So if you have anything that you need in your country, if there's stuff that you can't have access to or anything, please let us know in the questionnaire. As you can see, we have little gaps in the initiative, but we want to fill them, and we want to be able to provide more opportunities that you can benefit from. So please let us know in the questionnaire. And as all my colleagues said, we have amazing associations, we have amazing webinars, we have a lot of things going on all over the world. So keep your eyes open and try to join in all of them. And I think as you go through them, you'll be able to find the area that you like or that you're really interested in. So I think that would help you. But being here is definitely one step. I mean, you're here to learn about microgravity, hypergravity. That's a wonderful start. So I hope you stay for the whole webinar series, and then you'll find your interest and be able to leap to the next step. Thank you.
Yeah, thank you all for this very comprehensive answer to this question. So just remember to keep watching on our series of webinar. It will talk a lot from life science and physical science, and also technology demonstration. A lot of things, you cannot miss that. So yeah, I hope I did not miss some questions because we ran out of time, so I will call it a day. So if there's no questions, I will just take one more minute to mention that our next webinar is going to take place next week at the same time. But first, we would like to everyone that you register in our following webinars, and you will receive the link after your registration. Last but not least, please help us to fill in our questionnaire form. It helps us to improve our behavior, and it will take only several minutes. So just click the link and finish it now. Okay, so yeah, thank you everyone. Thank you, Miss Sirisha. Thank you, Dr. González and Jérémy and Arvalo, and also thank you, Hazuki. Yeah, thank you everyone to participate this webinar. Thank you everyone. Have a nice day.
Thank you, everyone. We hope to see you next week. Thank you.